Hi everybody, and welcome to this crash course on access to physics. Today's topic is the International System of Units, or the SI for short. This is your host, Cosmic Steve, and we'll be talking you through some basics to prepare you for all the lovely topics we'll be diving into. Okay, so what exactly is the SI system, I hear you say? The SI system is split into two parts. It is what scientists decided to use in order to quantify different types of measurements. The base units are used to determine and separate different measurements, and it is what separates a metre from a minute. To organise the different quantities of measurements, we use the SI prefixes. These two things are entirely independent of each other, but when they are both used together correctly, the results are harmonious. So when we say base units quantify different types of measurements, what we mean is whenever we measure something, we need some sort of descriptor dimension that we can add numbers to illustrate that which we are measuring. For instance, we use the dimension of length to measure how long something is, with the base unit of length being the metre. So, here's the important bit. We notate the SI base units by the letters we put after we have a quantity for our measurements, such as when we're measuring with a ruler, we would measure 2.5 metres. And in this case, we would write this as 2.5 m. That little m is the juicy bit we're trying to describe. By reducing the whole word to just the letter, we can reduce the space it takes up in the advanced equations, making it easier to read and giving us more room for other things. The base units themselves can be used to derive even more units, for even more complex measurements. To do this, all we have to do is multiply or divide different measurements into each other. For example, to create the unit of momentum, we multiply mass and velocity together, which equals mass in motion, momentum. Full disclosure, I'm not entirely sure if it's possible to do this with every unit. Let me know in the comments below if you know of a particular limitation of this method, as I'd love to hear it. So, in total, there are 7 base units, and in no particular order, they are: the base unit of length is the metre, m. We used to have a stick in a museum to tell us how long a metre is, but nowadays it's defined as the distance travelled by light in a vacuum, in 1,299,792,458th of a second. That's because light travels 299,792,458 metres per second. So if we divide 1 second by 299,792,458 metres, we get 1 metre travelled in 1,299,792,458 seconds. The base unit of mass is the kilogram, kg. They used to define it as the mass of a specific platinum iridium cylinder kept at the International Bureau of Weights and Measurements. But there was a recent development which allowed us to give the kilogram an unchanging value. It is really quite interesting if you'd like to take a deeper look. I'll put a link in the description below. The base unit of time is the second, s. It is defined as the duration of 9,192,631,777 periods of the radiation corresponding to the transition between the two hyperfine levels of ground state of the cesium-133 atom. It sounds very complicated, I know, but that's just so it has an unchanging value. All we really need to know is that it's made up of 100 milliseconds. The base unit of electrical current is the ampere, or amp for short, A. It is defined as 6.28 by 10 to the power of 18 electrons flowing past a point in 1 second. So 2 amps is twice as many, and so on. There are many different units associated with electricity in general, so I won't get too into this one to save the confusion. If you'd like to know more about electricity, I'll do an entire video dedicated to this topic. The base unit for thermodynamic temperature is the Kelvin, K. While most people think that this would be degrees Celsius or Fahrenheit, these are outdated scales, as 0 Kelvin is absolute zero, and the Kelvin uses this as its starting point. It is impossible to get below this point of thermodynamic temperature because absolute zero is a point where no kinetic energy occurs and therefore is causing zero heat energy. So Kelvin doesn't actually have a negative scale. The base unit for the amount of something is the mole, mol. 1 mole is defined as 6.02214076 times 10 to the power of 23 things. I use the term things lightly as the unit can be used to describe different things, whether it be atoms in a block, electrons in a circuit, or even pairs in a very large basket. The general gist is that it's the same number as there are elementary particles in 0.012 kilograms of the carbon-12 atom, and it can be used to describe how many things there are in something. And last but not least, the base unit for luminous intensity, or how bright something is the candela, CD. This is defined by hertz and watts per steradian. I'll probably do another separate video on that too. Now these are the 7 base units. Using these units, you can pretty much describe some basic physics of the universe. There are some derivations of these units and some other independent ones, but these pretty much make up the foundation of what you'll need to know to get started. As a quick exercise, write down each of the 7 base units and then turn over your paper. Pause this video now while you write them down. I will call out what each base unit describes and give you 5 seconds to see if you can remember which base unit matches to the description. Ready? Go! Okay, what base unit describes how much of something there is? The mole. Okay, what base unit describes thermodynamic temperature? The Kelvin. Okay, what base unit describes the mass of an object? The kilogram. And what base unit describes how bright something is? The candela. What describes a period of time? The second. What describes the electric current? The ampere. Finally, what describes a distance of length? The metre. Now, if you'd like to take a look at the other units, I'll enclose a link in the description so you can see just how many there are out there. Some of them are truly fascinating. I hope you enjoyed this video on SI base units. Stay tuned for the next episode on SI unit prefixes. We have been your hosts, Cosmic Steve, and I hope you have a wonderful time. Goodbye.